Good evening, everybody. This is Jack Long. I am the Mad Scientist, and tonight we're going to be discussing dust collection designs and layouts. And this is the extended version from the last one we posted, where we were just doing the basic system. Now we're going to take that basic information, we're going to expand that into a future shop and future expansion. So we're going to take those principles that we learned, we're going to expand on those. This is 3 out of 5. So with that being said, let's get into it. So let's say, for instance, that we have those same 3 machines where we have a 3-inch, a 4-inch, and an 8-inch. And over here we have a 3-inch, and a 3-inch, and a 3-inch. And I want to tie those back together into a common dust collector. But this dust collector already exists for this system, and we need to add these to it, but we need to not affect this system over here. So this is where you as a manager is going to come in and look at it and say, I can put some blast gates in this, and I can engineer this, put blast gates in it, and be able to still utilize this system over here for all of this. And so what we're going to do is let's go back, let's step back in here and let's look and see what our shaper's pulling 7. So this is going to be a 7.07, 7.07, and another 7.07. And so when we come together, we got 21.21 square inches. Where over here we had 68, 69, 60, yeah, 69. Let's just call this 70 for easy numbers. Okay, so let's just say this is 70. Obviously, if I took and fed this dust collector with this much air, I would starve that dust collector, which brings us to a point that you need to understand when we're sizing our dust collector about the air that's being fed in needs to match what the dust collector pulls. So if I fed a dust collector that is capable of 70 square inches and I fed it with 21 inches, what you will actually do is create the dust collector will pull its maximum CFM through these given ports of supply, and then that's it. Once it reaches its maximum static pressure, it cannot exceed that. Okay, so an easy way to explain that to you would be, imagine trying to take off and run a marathon and only breathe through a soda straw, for instance. You need to have more air feeding your fan. Okay, so if you starve your fan, you'll actually create so much negative static pressure on the backside of your fan that there is no fan, there's no air feeding the fan, and you will stall your fan, okay, because there's nothing for it to push. So what you have to do is you have to engineer into this system a means to make up this difference. So if I got 70 minus 21, it's going to wind up being 49? Yes, 49. I need to make up 49 square inches somewhere. So what you can do is you can do what they call leaving open ports, and you'll see this a lot on bigger systems where they would bring these pipes together, and so I would have my main trunk line would come over and I'd drop off from my 3, I'd reduce my pipe, I'd drop off from my 3, I'd reduce my pipe, I'd drop off from my 3. At the end of this, you leave a great big hole. And what you see is typically they will go in and they'll put expanded metal across the end of it. They call these bird cages, literally because the birds will fly by and get sucked into it. So it protects the system from foreign debris. Okay, but the purpose of this open port is to make up for this value right here. Okay, and you can add that air anywhere through the system. You could put it up here, you could put it back here, you as a manager would need to go through and figure out, are these 3 machines going to be at the tail end of your service, or are they going to be at the lead of your service? Okay. And then once you go in and do that, then you can put a blast gate here, and you can put a blast gate over here, and you can separate those 2, and you can run this off the same dust collectors, run this, and until you can justify upgrading the overall dust collector to take care of all 6 machines. Okay, so essentially that's all it is. You need to know when you are going in and laying your machines out, you need to know what size your dust ports are, and your dust ports will then tell you what your square area is. You'll take your square area and you'll calculate that out into your CFMs. Your CFM then feeds back and tells you what size your dust collector should be. Okay, so this has been, it was supposed to be like a 10-minute video, but if anybody has ever watched any of my videos, I have never made a short video, even though I've tried. And so once again, if you have any questions on this, it's not rocket science. It's all simple math, but you do have to run the numbers. You do have to stop and sit and think from a management standpoint where you're going to be at next week, next month, next year, so that as you're going through and you're laying your pipes out, your trunk line, stuff like that, that you take in consideration future expansion, which is why I keep going back to this NorFab system or the KF system, that snap together stuff. Because if I go into this and I decide that I'm going to go in and I'm going to upgrade this, what did we call this a while ago? It was a joiner, I think it was, or something. I don't remember what it was. But we go and upgrade this and we change this pipe size. Now what we can do is we can go back in and we can go in and redesign this system at minimal expense. All right, and maybe that means that I now take this 3-inch, add it over here onto this leg, and separate this off, and then put a bird cage at the end of here. And that's all easy to do because the stuff just snaps together. If you're getting the spiral pipe, then you have to go in, you have to cut the new spiral pipe, you have to retape the spiral pipe, and it's just a pain in the butt. Okay, so that kind of, I think, wraps up my dissertation on simple dust collections. Always interested to hear any questions, anything I can explain better. I did go through this kind of quick. As always, guys, be safe out there. We don't do anything that's worth going to the hospital for, so make sure that if you're up in the air that you got your fall protection and that you're taking care of yourself, because we all got somebody we want to go home to. And as always, let's go make a million. Have a great night.